Welcome to Vision Plus and welcome to this Senior 3 Additional Mathematics class. We are looking at functions and we are beginning with domain and range of linear functions. In example 1, we said a linear function is in the form y equals to mx plus c, which is the equation of a straight line. Example 2 says, find the domain and the range of the following functions. The two given functions are linear functions. So part A says we are given a function f of x equals to 7 minus 3x. For us to find the domain, which we have said, domain is a set of the values of x, which is the set of the input values. Domain is a set of the values of x for which f of x is well defined. We have discussed all these terms in our introduction. So in this case, for us to find the domain, these are just the values of x that do not disobey the two rules. What are the two rules that we talk about? We said rule number 1, never divide by 0. We don't need to divide by 0. For example, we are not supposed to get 8 out of 0 at any point. This is what we need to avoid at all costs. Rule number 2, we don't need square root of a negative number. No square root of a negative number in the real number system. In your complex numbers, you can get square roots of negative numbers. But in the real number system, we don't need to get square roots of negative numbers. For instance, root of maybe negative 9. We need to avoid this at all costs. We need to respect these two rules. But in your complex numbers, you can get this, which are imaginary roots, not real roots. So coming back to our domain is going to be the set of the values of x, which when we substitute that value of x here, we do not disobey these two rules when we are finding or when we get the output value of the function. And as long as the function is linear, any real input value of x here will give us the real output value of y. So the moment you see it a linear function and it is in the form of y equals to mx plus c, the domain will be a set of real numbers. Therefore, our domain is simply a set of all real numbers. Because for any real value of x that we substitute here, the output value of the function f of x will always be a real number. This implies that our domain will basically run from negative infinity up to positive infinity. This is in the interval notation. And in the set Bueller notation, our domain is a set of the values of x for which x is a set of all real numbers. This is the expression in the set Bueller notation. So this and this have the same implications. you just need to adhere to your question. If the question is specific that in the interval notation, you write this. But if they have said in the set builder notation, you write the second one. But if the question is open, you choose one of these. That is the domain for part A. Now let us go to the range for the same part A. Remember, we say range is a set of the values of the function y or the function f of x. These are the output values. For us to get the range, we say let the function y be 7 minus 3x, and then we make x the subject of the formula. When we make x here the subject of the formula, we shall have y minus 7 equals to negative 3x. Both sides by negative 3, both sides by negative 3. Our x as the subject of the formula becomes y minus 7 out of negative 3. So range now are the values of y, okay, the values of y that are predetermined by the input values of x. In other words, the range are the values of y that are well defined by the input values of x. Remember, this equation is linear. If we distribute the denominator, we shall have y out of negative 3 plus 7 out of 3. And for any real value of y that we substitute here, there is a real value of x. That means our range here is still a set of all real numbers. In other words, our range runs from negative infinity up to positive infinity. That is the set of any real number. Also, in the set Bueller notation, our range, which is set y, is a set that comprises of real numbers. So this is the range for this function. So as long as it is linear and it has the two terms, just x and y, both the range and the domain will always be sets of real numbers. So this is the answer for part A. And now going to part B, we are still finding domain and range in example 2. So the domain here, which is the set of the real values of x, for which f of x or the function y is well defined, will be, since it is a linear equation, for any real input value of x that we substitute here, there is always a real output value of y. That implies our domain is a set of real numbers. As long as the function given is linear and it has y and x in it, then the domain and even the range will always be sets of real numbers. In the interval notation, the domain is from negative infinity up to positive infinity. In the set Bueller notation, the domain is a set X comprising of the real values of X. In your exam, or when the question is specific, use the two answers accordingly. This is the interval notation. This is the set Bueller notation as clearly explained in the introduction. And now going to the range. Range is the set of the values of y that is well defined by the domain or the values of x. I have just said as long as the function is linear and it has the terms in y and the terms in x, it means both the domain and the range are sets of real numbers. And in part A, we started by making x the subject of the formula. But in this example, we shall not do that. But they are both the same. The key thing here is, once you have seen it is linear, it has x and y, then both the range and domain are sets of real numbers. Therefore, our range here, without wasting time, is as well a set of real numbers, set of all real numbers. And to express this mathematically, range is a set of numbers running from negative infinity and reaching positive infinity. This is the interval notation. In the set Bueller notation, our range is a set y comprising of all the real values of y. This is in the set Bueller notation. So what is the key takeaway here when you are dealing with linear functions? An NB here, if it is linear, with x and y terms, if the given function is linear and it has both x and y terms, then both the domain and the range are sets of real numbers. So you just have to be careful. Examine, confirm that it is linear, check through the linear equation. If there is a term in x and the term in y, it means both the range and the domain will be sets of real numbers. And then you can express them in either interval notation or set Bueller notation. Otherwise, this is the solution to example 2.